Entrancing, more so than the last. At any rate, a late revelation has caused a critical parting between analysts as they examine the data. Now, the fiercely expected depiction of clarity has appeared, as renowned astrophysicist Neil deGrasse Tyson uncovers the dazzling discoveries in space. Join us as we explore how Pioneer 1 identified 500 dark objects passing through space, and find Tyson's thoughts on this astounding discovery. On June 30, 1908, a stony space rock collided with Earth, striking a city in Siberia, Russia. The solid impact of this event resulted in the leveling of around 2,000 square kilometers. The critical degree of this event resounded globally, causing an overall shockwave. This research prompted the publication of the Certain Union Among Cosmology and the Military by Neil deGrasse Tyson, wherein he highlighted the blend of legitimate examination and public security, advocating for extended interest in space exploration to safeguard our planet. This outstanding work changed public awareness surrounding the importance of space exploration. In a shocking turn of events, NASA's space apparatus, Pioneer 1, has just recognized 500 dark objects passing by in space, leaving analysts astounded. Neil deGrasse Tyson, the incredibly well-known astrophysicist, has emerged to give further essential clarity. However, as analysts dove into the mystery of these 500 unidentified things, they unexpectedly stumbled upon a stunning revelation about Voyager 1 itself. But before we explore that revelation, we should first familiarize ourselves with the critical Pioneer 1 rocket. Pioneer 1, the courageous space trailblazer, has already traveled an astonishing 145 billion miles from Earth. The speed at which the rocket moves through space is truly staggering, covering a distance approximately 3.6 times the space between Earth and the Sun every year. However, there's another side to the interstellar test than just its speed, life expectancy, and distance from Earth. Pioneer has sent a number of remarkable discoveries to us, such as the recent 500 dark objects it identified out there in the vastness of space. These are strange, wonderful objects that we've never seen or understood before. We'll get into that huge uncover in a moment, but there's a question that is likely at the very front of your thoughts right now. How could a rocket that was launched back in 1977 still be working and sending such vital information? Well, the answer lies in the stunning planning and foresight that went into Voyager 1's design. One of the key factors contributing to its longevity is its dual redundant computer systems. Every Voyager rocket, including Voyager 1, was equipped with two sets of onboard computer subsystems, the Flight Data Subsystems, FDS, and the Altitude and Attitude Control Subsystems, AACS. This redundancy served as a critical safeguard, allowing continuous operations between systems and the ability to replace faulty computer parts, thus extending their life expectancy. The computer systems on board Voyager 1 and its twin, Voyager 2, were designed as a distributed architecture with 3 redundant sets of computers. This redundancy ensured that, even if one system failed, the others could take over, preventing major disruptions. To save power, Voyager's instruments relied upon engineered logic. This means that the computer systems were designed with special circuits to ensure they could operate within the constraints of power budgets and time limits during the rocket's journey. Power management is critical in maintaining Voyager 1's operational integrity. The rocket's distance from the Sun, where it can harness solar energy, presents a major challenge to maximizing power efficiency. Engineers had to come up with creative ways to manage and optimize power usage. One key part of power management involved turning off non-essential systems. Engineers carefully assessed which parts or subsystems were not critical for the main mission goals. For instance, heaters connected to certain scientific instruments were deactivated. These heaters were originally designed to maintain instruments at specific temperatures for optimal performance. By turning them off, power consumption was significantly reduced, thereby extending the spacecraft's overall lifespan. This decision to deactivate unnecessary systems is not made lightly. It requires a careful evaluation of trade-offs between power conservation and the scientific objectives of the mission. Engineering teams collaborate closely with scientists to ensure that deactivating specific systems does not compromise the quality and availability of scientific data. The goal is to find a balance that maximizes power efficiency while maintaining essential functionality. But that's not all. Voyager 1's power management systems also adapt to the changing conditions of its environment. As the spacecraft travels farther from the Sun, the available solar energy decreases. To compensate for this, Voyager 1 adjusts its power usage accordingly. This adaptive approach ensures that available power resources are efficiently allocated to support critical operations and data transmission. Over the years, there have been ongoing technological advances and improvements in power management techniques, allowing engineers to refine and further enhance the power systems of the Voyager probes. These advancements include more efficient power distribution, better battery charging methods, and improved power regulation and control. Thanks to these rigorous power management systems, engineers have successfully extended Voyager 1's operational life expectancy, enabling it to continue its scientific journey through the universe. Considering that the spacecraft was initially expected to last only 5 years, the fact that it's still sending back data nearly 50 years later is truly remarkable. It highlights the dedication and expertise of the scientists and engineers who have worked tirelessly to keep Voyager 1 functional. However, even with this careful planning and engineering, the depths of deep space remain mysterious. Stay tuned, because a huge discovery is coming. What did Voyager 1 find? What did Voyager 1 uncover that stunned specialists? While there are several broad theories about what Voyager may encounter, meteoroids, space rocks, and asteroids, there's always the potential for alarming surprises. One such incredible twist in the Voyager 1 mission was its discovery of 500 mysterious objects. This revelation caused quite a stir and raised serious concerns among the researchers managing the mission. These odd signals and anomalies in the data came as a complete shock. Adventurer 1 started conveying telemetry data back to Earth, yet the readings were unusual and there was no undeniable explanation for what was going on. The scientists marked this characteristic a puzzler. Yet, in spite of some unacceptable transmission, Traveler 1 continued to answer orders from Mission Control, but with a slight delay in correspondence. This was a befuddling situation, and it became the secret. What was especially dazing about this oddity was that it didn't set off Pilgrim 1's onboard issue security systems. These systems are expected to initiate when abnormalities are recognized, setting the transport into an exploratory mode that permits architects to explore and break down the issue. For this situation, anyway, Investigate 1 continued with its tasks without entering exploratory mode, adding to the interest. Later, exhaustive assessment, the characteristic was tracked back to the Height and Explanation Control Subsystem, AAC. The AAC plays a basic part in authoritatively organizing the space device and controlling its developments. Roughly 22 minutes for a radio motion toward movement one way between Earth and Traveler 1, this critical time delay presents difficulties for ongoing correspondence and order execution. Notwithstanding these difficulties, the mission group successfully executed the fix to divert telemetry information to the working installed PC. Anyway, the process was not without its intricacies. Given the immense distance between Earth and Adventurer 1, even straightforward communication orders took some time to reach the rocket, and the ensuing reaction likewise had a huge delay. In any case, the fix was eventually executed, and telemetry data started coursing through the right channels, giving clearer and more exact data about the space climate encompassing Pilgrim 1. With the oddity settled, researchers could now zero in on examining the data gathered by the shuttle. As scientists dug into the telemetry information, they made a frightening disclosure. Among the 500 unidentified items distinguished by Pilgrim 1, there was a subset of items showing exceptionally uncommon qualities. These objects exhibited inconsistent movements, sporadic shapes, and unusual ghostly marks, unlike any known galactic peculiarities. At first, excused as instrumentation blunders or noise, further investigation uncovered reliable examples in the conduct of these atypical items. They seemed to challenge customary clarifications and tested existing models of divine elements. Researchers were perplexed by the nature and origin of these confounding substances. The discovery of these strange objects ignited intense discussion and hypothesis inside mainstream scientific communities. Some analysts proposed colorful hypotheses, including extraterrestrial intelligence or, alternatively, advanced drive systems, while others still had doubts, pushing for more conventional explanations. In light of these discoveries, Neil deGrasse Tyson said something regarding the significance of Pioneer 1's discovery in a series of meetings and public statements. Tyson stressed the importance of maintaining scientific meticulousness and skepticism while investigating the unknown. He forewarned against rushing to make untimely judgments and asked specialists to conduct intensive investigations before drawing any definitive conclusions. Tyson's measured response to the revelation of the mysterious items helped temper drama and encouraged a deliberate approach to scientific inquiry. He stressed the need for continued observation, data collection, and investigation to unravel the true nature of these confounding phenomena. In the months following the initial discovery, researchers all over the world assembled efforts to study the strange objects identified by Pioneer 1. Observatories, space telescopes, and ground-based instruments were focused on the areas of space where the abnormalities were noticed, assembling additional data to supplement the rocket's observations. Slowly, a clearer picture began to emerge as researchers sorted out the puzzle of the mysterious objects. Through meticulous analysis and cooperative research efforts, they uncovered clues about the objects' origins, compositions, and behaviors. While many questions remained unanswered, each new revelation brought researchers closer to understanding the nature of these infinite puzzlers. As the investigation into the puzzling objects identified by Voyager 1 continues, researchers remain focused on unraveling the mysteries of the universe. Their dedication to exploration, revelation, and understanding serves as a testament to human curiosity and the pursuit of knowledge. The soul of interest and revelation in the end, the revelation of 500 unidentified items by Voyager 1 addresses a turning point in the history of space exploration. It has tested how we might interpret the universe and opened new roads for logical inquiry through cautiously contemplating these cryptic peculiarities. Researchers desire to uncover the secrets of the universe and expand how we might interpret its complexity and variety. Hours for a request to come to the spacecraft, this time delay adds a layer of multifaceted design to talking with Voyager 1. The mission team must carefully plan and execute commands considering the expected response time. Any missteps or issues can lead to unforeseen difficulties and complications during the anomaly assessment. This time delay addressed an outstanding challenge, which meant that suggestive and research processes were fundamentally delayed. Orders must be meticulously made, keeping in mind the 22-hour waiting period before receiving any confirmation or response from Voyager 1. But here's the incredible part: despite the massive time delay, each message sent to Voyager 1 was not just adding to the data, it was a crucial part of the mission. The time delay could limit ongoing control and communication, but it didn't reduce the significance of the communication. Each message was an essential piece of the puzzle in solving the anomaly. In the end, the anomaly was fixed at its source, and the defective computer was shut down. Voyager 1, the marvelous spacecraft, could then continue its stunning journey through the vastness of space, sending back valuable data and insights to Earth. Now that we know the previous issue with the space probe has been resolved, let's look at the remarkable accomplishments of the spaceship when it had no issues. The primary objective of the astounding spacecraft, launched on September 5, 1977, was to explore our nearby planetary system, but its mission extended beyond that. Voyager 1's story began with an exciting twist. Long before reaching Jupiter, it began transmitting pictures of the gas giant. These early images, showing Jupiter's brilliant spinning clouds and the notorious Great Red Spot, were an instant hit at NASA's Jet Propulsion Laboratory. However, this was just the introduction to a journey that would redefine space exploration. The first major revelation came with the discovery of active volcanoes on Jupiter's moon Io. This intriguing moon, somewhat larger than Earth's moon, held the secret of being the most volcanically active body in our entire solar system. Voyager 1's instruments detected unusual signals from Io, and the specific images it captured revealed a vast expanse of towering volcanic peaks and a surface scarred by the eruption of volcanic material. Among these was Pele, one of Io's most prominent volcanoes, which has erupted as high as 30 times the height of Mount Everest, covering an area almost the size of France. The secrets of our nearby solar system were unfolding before our eyes. Before the new mind-bending discovery of 500 unknown objects passing by in space, the twin Voyagers had already been astounding us since their launch. Perhaps their most astonishing discovery was the presence of Jupiter's rings. These delicate rings, though faint, added an air of mystery to the already puzzling gas giant. Voyager 1 added another piece to the riddle by revealing that Europa, one of Jupiter's 53 named moons, was encased in a frozen shell more than 60 miles thick. This challenged our previous assumptions about the nature of distant celestial bodies and sparked a new wave of interest in the potential habitability of icy moons. But there's more. As the Voyagers bid farewell to Jupiter, they received a critical farewell gift, a gravity assist. This gravitational slingshot propelled them towards Saturn. Without it, they would have been caught in the Sun's gravitational pull, unable to venture further into space. Voyager 1's path then took it close to Saturn's intriguing moon Titan, shrouded in an orange, cloudy atmosphere. Titan's mystery piqued researchers' interest, prompting in-depth studies of its complex chemistry. Voyager 1 then set its course toward the outer solar system, leaving the plane of the planets and embarking on a journey beyond the planetary system. Amid all these discoveries and wonders, one individual played a pivotal role in expanding the mission beyond its initial objectives, the renowned astronomer Carl Sagan. As a member of the Voyager mission's imaging team, Sagan passionately advocated for one final set of images before shutting down the spacecraft's cameras. These images, he believed, would serve as a token to humanity, offering a final glimpse of our home planet from the depths of space.